Hello, Hoptown students. This is Mr. Martin. Hello, Hoptown students. Well, hold on. Hello, Hoptown students. Mr. Martin. Hello, Hoptown students. Mr. Martin here. And what we're going to be doing the rest of the unit is talk about something called scientific notation. Now, this is going to take us a few days to talk about, but we got to start with what is scientific notation and what do we use it for? Well, let's go ahead and say what we're going to use it for. Scientific notation is a quick way to write a really, really big whole number in a little bit shorter way. We're going to do that part today, but we're still going to be working with numbers in the thousands and the millions because we just want to get used to it before we even think about a very, very big whole number. And then we're going to talk about afterwards turn really, really small numbers into scientific notation, and those are going to be decimals, long decimals, 0 point something, but it goes out many decimal places. So our target today is, once again, we're going to be working with whole numbers today. So when we write scientific notation today, it's going to be dealing with whole numbers. I will convert numbers between scientific and standard notation. Working with whole numbers though, you need to get this target down. You can pause the video, get the target down, and then you can push play. The reason we do this is, well, I love this part, mathematicians and scientists are lazy. Instead of writing very long numbers over and over again, they decided about using powers of 10. That means 10 is not going to be your exponent. 10 is a base here. They can create short versions of long numbers. And when we work with scientific notation, it's always the 10 base or base of 10 will always pop up in scientific notation, no matter if we're dealing with a long whole number or a long decimal. But what do we need for scientific notation? You need to get this slide down. The rules for scientific notation. To be in proper scientific notation, the number must be written with 1. A number between 1 and 10. That means either a whole number, 1 through 9, or some type of like mixed decimal, things like 2.3, 5.6, 9.8. It could even go out to 7.85, 6.543. We just need a number between 1 and 10. More on that in a second. Then we're going to show it being multiplied by a power of 10. And this is, we're going to have to decide how to determine what exponent goes on our power of 10, but we're going to do that when we start doing examples. But the first thing I want to ask you is, look at these two things we need, and look at this down here. It says 23 times 10 to the 5th power is not in proper scientific notation. Why? Which part of our instructions here does it not fit? Well, obviously, it doesn't fit a number between 1 and 10 because 23 is bigger than 10. If this was in proper scientific notation, that should be 2.3 because 2.3 is between 1 and 10. So that's just something we have to keep in mind when we're writing things in scientific notation. So here's our first example. 137,000 can be rewritten as 1.37 times 10 to the 8th power. Now let's look and see why this can be that, how we turn something into scientific notation. Sure, we can do order of operations down here and prove that this is that, but that's not going to, do you really want to guess and check like that all the time? I would not. So basically turning numbers into scientific notation and standard notation into scientific notation is almost like when you worked with percents and decimals. Because really all you're going to do is move a decimal over. When we look at this big long number, your decimal point is at the end of this number right now. The first thing we need is a number between 1 and 10. So what we're going to do is move this decimal until we get a number between 1 and 10. Now if we stopped here, that decimal would be 137. That's not between 1 and 10, so we keep moving. If we stop there, that would be 13.7. Well, that's still bigger than 10, so let's move it one more time. If we stop there, that would be 1.37, which is exactly between 1 and 10. So this is where we put our decimal, and that's where this comes from. Now, where does our exponent come from? Well, our exponent comes from how many times we had to move it. So since we're moving it to the left here, we're going to count over how many times we moved it. So we start here with 1, 2, 3, 4, 5, 6, 7, 8. And that is where our exponent comes from. It is the place. It is how many places the decimal moved. When we move that decimal over, go ahead and put the little, you can put the little tick marks in if you want to, until you hit a number between 1 and 10. You write that number down, then you go back and just count how many times you moved it. And that's what's going to be on your base 10 there. And that's how we turn standard notation into scientific notation with whole numbers. So our next slide is going to be a couple examples for you to do. So we have 3 numbers here. I'm going to help you with the first one, then you're going to do this next 2 on your own. But let's look at the first one. Our decimal point's already in place, ready to move. You're going to have to put the decimal point there usually yourself, but I went ahead and put it there for you. So this is where we're going to start from. So the first thing we need is a number between 1 and 10. So we're going to move that decimal over until we get a number between 1 and 10. In this case, our number is going to be 3.47. Well, now we're going to count up how many times we moved that decimal. So 1, 2, 3, 4, 5. So we moved it 5 places. So that means it's going to be multiplied by 10 to the 5th power, and there's your scientific notation. So let's see if that matches with this. Yes, it does. That's all you're doing, turning a whole number, a long one, into scientific notation. So I want you to pause and do these 2 on your own. We'll see how well you handle this, okay? Now let's see what you did. We had 902 million. Let's see what that is in scientific notation. Our number this time between 1 and 10 is 9.02, so the decimal's right here. And how many times did we move the decimal to get there? Well, we moved it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So there's your number in scientific notation. Our last example here is 61,400. Well, that's not going to be as hard as as long as this one. But the number in scientific notation there, it's going to be hard to see, but I'll tell you, with all this stuff down here, I'll tell you what it is. It is 6.14, so 6.14, that's between 1 and 10, times 10 to the 4th power, because that decimal got moved 1, 2, 3, 4 places to get there. And that's all. That's how you turn standard notation, your regular number, into scientific notation. Now, what we're going to do now is reverse the process. Let's say you had scientific notation to start with, and you're going to turn it back into standard notation. In other words, the number that we can actually read and understand. Let's start with the first example. First example says you have 1.23 times 10 to the 5th power. So the first thing you're going to do is write down the 1.23. And then what you're going to do is count to the right 5 places, because this is saying right here that this number is bigger than that. So let's go ahead. So 1, 2, 3. No place there, put a 0. 4. So we've gone 4 places so far. 5. So it should be 123,000. Well, let's see if that's correct or not. And yes, it is. So you're just kind of reversing the process that you did just a while ago. So try this one out on your own and see what happens, and see if you do well in this second example. Okay, let's see what you got. We had 6.14 806 times 10 to the 6th power. In standard form, that is 6,806,000. So if you had that, you're A-okay. Now, sometimes people, when they start working with this, may be a place value off. Well, we can always work on that. This is, this is going to be a pretty simple concept to pick up on. It's just, I think a lot of the problems here is going to be the counting, how many places you move the decimal, because that seems to be the problem. So let's move on to some more practice problems. Two of these problems you're going to write in scientific notation. And the other two you're going to write in standard notation. I want you to take a few minutes and do that for me. Pause the video, play it when you want to see if your answers are correct or not. Well, let's see how you did. The first number was 4,000. In scientific notation, that would be 4 times 10 to the 3rd power. Because 4 is our number between 1 and 10, and in order to get to that 4, we had to move that decimal 3 times. Our second example, we're turning into standard notation. So we're starting out our decimal here, and what this says here, we're going to move it to the right 3 times to make the larger number, and rewrite in standard notation. So our answer there is 2,480. Here's our third example. You had 6.123 times 10 to the 6th power. Well, this is saying here you're going to move this decimal to the right 6 times. So, let's see what you ended up with. Did you end up with 6,123,000? If you did, you're A-okay. Our last one is writing a number in scientific notation. So your decimal's here, and you're going to move it over until you hit a number between 1 and 10. And then you're going to count up how many times you moved it. Let's see what you did. Well, it's 3.06 times 10 to the 8th power. If you got all 4 of these right, you'll have no problem with this, and you'll have no problem with the assignment we're going to be doing. If you missed one, just a little practice, and this assignment will give you enough practice. If you missed more than one, you may want to make sure you're counting right, because it may not be the decimal here or anything like that's causing you a problem. It may be moving that decimal over, or forgetting to put zeros in when you skip a place that doesn't have a zero, doesn't have a number in it at all, or you're miscounting moving the decimal. I hate the bell. In the United States, 15 million households use private wells for their water supply. Write this number in scientific notation. It's already in standard notation. You're going to write it in scientific notation. I want you to pause the video and do that for me very quickly. Well, let's see what you ended up with. What you should end up with is our number between 1 and 10 is 1.5 times, because we're multiplying, it says multiply by a base 10, 10 to the 7th power. The 7 is how many times you moved that decimal from here until you got to the 1.5. If you got that right, you're A-okay. Let's look at a second example of a word problem. Well, this one, they give you scientific notation. The U.S. has a total of 1.2916 times 10 to the 7 acres of land reserved for state parks. Write this in standard form. Anytime you see standard form, they want the actual number that represents. So I want you to do this problem real quick for me. Pause the video, play it, just check your answer. Well, let's see what you ended up with. What number is that scientific notation trying to tell us? Well, it's 12,916,000 acres of land. So one of the reasons we do that is to kind of avoid doing these numbers here. But if you notice, it's probably going to take the same amount of space to write this to that. But keep in mind, we're doing it with smaller, even though 12 million something is a big number, we're doing it with smaller numbers just to get you used to this. And pretty much if you got this all right, then you pretty much are mastering writing whole numbers into scientific notation, and scientific notation the whole numbers. I hope you have a good evening.